Today we're going to introduce our trigonometric functions, talking about the unit circle. So first I'll define for you what the unit circle is. The unit circle is the circle that is centered at the origin that has a radius of 1. So when you draw it centered at the origin with a radius of 1, there are 4 ordered pairs you should be able to get without really thinking about it. You've got these axis ordered pairs, 1, 0, 0, 1, negative 1, 0, 0, negative 1. So here are our 6 trigonometric functions we're going to discuss. So if theta is any central angle, which looks like this, any central angle on this circle, here's your angle here with a radius of r, and it touches this ordered pair x, y. The sine of that angle theta is actually the y value of that ordered pair. The cosine of that angle is actually the x value of that ordered pair. And the rest of the trigonometric functions are actually defined by sine and cosine. Your tangent of that angle is the sine of that angle divided by the cosine of the angle. Well, since we said the sine was the y value and the cosine was the x value, then the tangent must be y over x, and of course x can't be equal to 0. Now the next 3 trig functions are called reciprocal trig functions. The first one we have is the cosecant. The cosecant is the reciprocal of the sine, so cosecant is equal to 1 divided by the sine of theta. Well, again, we said the sine of theta was y, so the cosecant is 1 over the y value, and of course y can't be equal to 0. The secant is the reciprocal of the cosine function, so secant is equal to 1 over the cosine of theta. And again, we said cosine was x, so it would be 1 over x. X can't be equal to 0. And then the next one is the cotangent. Now the cotangent is the reciprocal of the tangent. Well, if you recall, we said tangent was sine over cosine, so the cotangent would be the reciprocal, cosine over sine, or x over y, and of course the y can't be 0. Now, when most people refer to a unit circle, they're actually talking about this circle right here, where there are a bunch of angles that are highlighted and ordered pairs that are highlighted. So we'll talk about this and we'll use this for the rest of the semester. Here are those axis angles that we talked about, 0, 90, 180, and 270, with those ordered pairs 1, 0, 0, 1, negative 1, 0, 0, negative 1. And then we have these angles right here, 30, 45, and 60, which are really going to be useful. We're going to need to know those like the back of our hand starting almost immediately, and the ordered pairs that go along with them. And then we'll define the rest of this unit circle later in the semester. So using that unit circle, let's find all 6 trig functions for the angle pi over 2. So what you need to do is find the angle pi over 2 on the unit circle and find the ordered pair that's associated with it, which is 0, 1. Then using the definitions that we just discussed, the sine is going to be the y value, which is 1. Then once you have the sine, it's pretty easy to find the cosecant. You just take the reciprocal, 1 over 1, which is 1, so the cosecant of pi over 2 is also 1. Remember, the cosine is the y value, so the cosine of pi over 2 is 0. And then the secant will be the reciprocal, which would be 1 over 0, but of course we know we can't divide by 0, so we actually say that the secant is undefined. And the tangent, which is sine over cosine, would be the y value divided by the x value, or 1 over 0, another one that's undefined, so the tangent of pi over 2 is undefined. And the reciprocal of 1 over 0 would be 0 over 1, or the cotangent, which is cosine over sine, or x over y, would give us 0 over 1, or 0. Let's do another example. Let's find all 6 trig functions for the angle pi. So again, we go back to that unit circle. I highly recommend that you print one. You find the ordered pair associated with pi, which is negative 1, 0, and then you have your x value and your y value. Using the definitions of the 6 trig functions we just went through, you can define all 6 trig functions. So we'll start with the sine, which is the y value, which would be 0. Then we can find the cosecant, which is the reciprocal, would be 1 over 0, which again is undefined. We can find the cosine, which is the x value, which would be negative 1. And then the secant would be the reciprocal of that 1 over negative 1, which reduces to negative 1. The tangent, which is sine over cosine, or y over x, would be 0 over negative 1, or 0. And the cotangent would be negative 1 over 0, which is undefined. So now let's pick one of the non-axis angles. Let's just pick some other random angle. So we'll do another example, and we'll find all 6 trig functions for 7 pi over 6. So again, you need to go back to that unit circle, find the ordered pair that's associated with 7 pi over 6, which is negative square root of 3 over 2, comma, negative 1/2. You have your x value, you have your y value. You can now use those definitions of the 6 trig functions and find all 6 trig functions for this angle. The sine again is the y value, so that would be negative 1 over 2. The cosecant would be the reciprocal of that, which would be negative 2 over 1, which reduces to negative 2. Now the cosine is the x value, so that would be negative root 3 over 2. And the secant would be the reciprocal of that, which would be negative 2 over root 3. But we're going to have to do something called rationalizing this. We try not to have square roots in the denominator, so we'll take this negative 2 over square root of 3 and we'll multiply the top and the bottom by the square root of 3. The 2 times square root of 3 gives me 2 root 3, and root 3 times root 3 gives me 3. So the answer we're actually going to see the secant of 7 pi over 6 written as is going to be negative 2 root 3 over 3. We do try to rationalize these. Now, to find the tangent, we'll take the y value divided by the x value. So we'll take that negative 1/2 divided by negative root 3 over 2. Dividing by fractions, you'll take that top fraction and multiply by the reciprocal of the bottom fraction. Now notice the 2's will cancel, and a negative times a negative gives us a positive, and we have 1 over the square root of 3. We will have to rationalize again, so we multiply the top and the bottom by the square root of 3, and the tangent of 7 pi over 6 is square root of 3 over 3. Now, when you go to find the cotangent and you just take the reciprocal of the tangent, if you take the reciprocal of root 3 over 3, then you're going to have to rationalize again. So if you actually just go back before you rationalize the 1 over square root of 3 and take the reciprocal of that, you would get that the cotangent is root 3 over 1, which just reduces to root 3, and that saved you from having to rationalize again. So here we have this unit circle again. I'm bringing this up again, and every angle on here can be accounted for. We'll talk about it in degrees. You've got 0, here's about 10 degrees, 20, 30, 45, 90, all the way to 180, down to 270, 360, and then if you keep going, like 365 would be right here, and 85 would be right about here, and you can keep on going and going and going around. And you can also, all the negative angles are accounted for. So for sine and cosine, the domain is all real numbers. You can plug in any angle you want, whether you do it in degrees or radians, it's not a big deal. Now the range, however, let's discuss that. Since on this unit circle, every angle is accounted for, and knowing that the sine is the y value, notice that the largest y value this circle takes on is 1, and it takes on all the ones down to here to negative 1. So it turns out that the range of the sine, when you take the sine of any angle at all, it's going to be between negative 1 and 1. And the cosine being the x value, notice the largest x value this circle takes on is 1. It takes on all the x values down to negative 1. So the range of the sine and the cosine are both negative 1 is less than or equal to the sine, and the cosine of any angle at all is less than or equal to 1. So regardless of what angle it is, whether it's a positive angle, a negative angle, it's in degrees, it's in radians, it doesn't matter how many times you rotate around the circle, anytime you take the sine or a cosine of any angle, you'll always get values between negative 1 and 1. Now I have a definition for you. A function is called periodic if there exists a c such that f of x plus c is equal to f of x, and the smallest such c is called the period. Turns out that sine and cosine are both periodic functions with a period of 2 pi, or 360 degrees. So what that means is every 360 degrees, every full rotation around the circle, whether you go clockwise or counterclockwise, your sine and your cosine are going to repeat. So here, I don't know what this angle is. Let's say it's, 75 degrees. So here, when you go 75 degrees, you get this x value and this y value, and you can define your sine of 75 degrees based on those values. But if we did one full rotation around the circle and a little bit more and ended up back there, notice the x and the y value don't change. Even if we started here and we went backwards for that negative angle and ended up here, no matter what, the x and the y aren't going to change. Now, if you recall from previous knowledge, angles that start with the same initial side and end at the same terminal side are called coterminal angles. So because they end at the same terminal side, they're ending at that same ordered pair, they have the same x and y value of that ordered pair. Trig functions of coterminal angles are the same. So we can use this to our advantage of finding sine and cosine of angles that aren't actually on the unit circle. For example, if we wanted to find the exact value of 7 pi over 3. So far up to this point, what we know to do is to go back to the unit circle, find the angle 7 pi over 3, and use that x and y value to determine what the sine and the cosine are. The issue is 7 pi over 3 isn't on the unit circle. It's actually too big. If you were to convert that into degrees, you would realize that that's over 360 degrees, or you can see that it's over 2 pi. So let's find a coterminal angle. And remember, to find coterminal angles, you either add or subtract 2 pi. Because this angle is positive and it's too big, we'll subtract 2 pi, find our common denominator, and we'll get pi over 3. So 7 pi over 3 and pi over 3 are coterminal. They end at the same ordered pair, so they have the same x and y. So the cosine of 7 pi over 3 is going to be the same value as the cosine of pi over 3, which turns out to be 1/2. Let's do another example. Let's find the tangent of negative pi over 4. And again, if you look at your unit circle, you'll realize that negative pi over 4 is not on the unit circle. So let's find a coterminal angle that is. Now notice all the angles that are on the unit circle are positive, so we'll find a positive coterminal angle by adding 2 pi. And when we do and we find our common denominator, our coterminal angle is 7 pi over 4. So because trig functions of coterminal angles are the same, then the tangent of negative pi over 4 would be equal to the tangent of 7 pi over 4, which is the y value divided by the x value. Take negative root 2 over 2, divided by root 2 over 2, and you get negative 1. So the tangent of negative pi over 4 is negative 1. Another definition for you, a function is called odd if when you plug in a negative x value, you get the opposite of when you plug in the positive x value. And a function is even if when you plug in a negative x value, you get the same thing as when you plug in a positive x value. Fact: sine, cosecant, tangent, and cotangent are all odd functions. So the sine of a negative angle is the opposite of the sine of that positive angle. The cosecant of a negative angle is the opposite of the cosecant of the positive angle. The tangent of a negative angle is the opposite of the tangent of the positive angle. And the cotangent of a negative angle is the opposite of the cotangent of the angle. Cosine and secant are even functions, so when you take the cosine of the negative angle, you get the same thing as if you take the cosine of the positive angle. Secant of a negative angle is the same thing as the secant of the positive angle. Now, if you recall from the example that we just did, the tangent of negative pi over 4 is equal to 1. Well, using the odd identity, we know that the tangent of negative pi over 4 is going to be the opposite of the tangent of pi over 4. So if you go to pi over 4 on the unit circle and you do y divided by x, you would get root 2 over 2 divided by root 2 over 2, and the opposite of that would be negative. So the tangent of pi over 4 is 1, and the opposite of that would be negative 1. So you can solve this problem either way. You can either do what we did where we found a coterminal angle on the unit circle, or you can use the odd identity. Let's do one more example. If we knew that the sine of negative t was equal to 5 over 9, let's find the cosecant of t. Well, using the fact that sine is odd, we know that the sine of negative t is the opposite of the sine of positive t. Well, we just said that the sine of negative t is 5 over 9, so 5 over 9 is the opposite of the sine of t. Divide both sides by negative 1, and so the sine of t would be negative 5 over 9. Remember that the cosecant is the reciprocal of the sine, so the cosecant of t would just be the reciprocal of that, or negative 9 over 5. Thanks, and I'll see you next time.